We are going to look at indicial equations in our videos today. Thank you so much for watching. I hope you've watched the first two videos on binary operations and the other videos we made on indicial equations because these videos have something in common. But before I continue solving the problem on the board, I would like you to remember to subscribe to this page, like the video, and then share it so that others can watch it. Now let's look at the question on the board. If 2 index 2x minus 3y is equal to 32, and log x base y is equal to 2, find the values of x and y. Now, for us to solve this problem, we need to remember that there's a relationship between indices and logarithm. Let's look at that relationship. If 2 to power 3, of course this is 8 because this is 2 times 2 times 2 is equals to 8. Then log 8 base 2 is equals to 3. And let me take another one. If log 1000 base 10 is given to us, let's say this is equal to x. Automatically, to convert from this to this, we need to cross multiply by writing that 10 index x is equals to 1000. And 1000 the same thing as 10 index 3. So equating the indices, it is clear that x is equal to 3. So with that in mind, we can begin to solve this. Now let's begin with this, convert this to indices so that you can be able to work with this. So log x base y is equals to 2. It implies that y squared is equals to x. Let's call that equation 1. Now look at the second equation, we have that 2 index 2x minus 3y is equal to 32. You know that 32 is the same thing as 2 to the power 5 because 2 times 2 times 2 times 2 times 2 is equal to 32. Now let's equate the powers to have that 2x minus 3y is equal to 5. Now, if you have this way, let's call this equation 2. And but in our equation 1, we have that x is equal to y squared. So when we have x, we can plug in y squared there so that this becomes 2y squared minus 3y is equal to 5. Um, let's leave it the way it is. Now we can use additive inverse of 5 to make this a quadratic equation. So that will mean 2y squared minus 3y minus 5 is equal to 0. Okay, so how do we go about solving this problem? First, let us divide all through by 2 in order to make the coefficient of y squared to be 1. So if we divide all through by 2, we are going to have y squared minus 3 over 2y minus 5 over 2 is equal to 0. I know that not everyone is familiar with this method of solving quadratic equations, but this is what I want to use so as to persuade many of my students to study it. It would have been easier for me to just factorize this, but I don't want to go into that. I want to do something that in the long run, when you get to know this method, it will help you to solve all quadratic equations without thinking of the formula method or any other method of solving quadratic equations. Let's continue. Now, at this point, I want to pick 3 over 2 and then the product. You know that if alpha and beta are the roots of a quadratic equation, right, of ax squared plus bx plus c is equal to 0, then you want to use this to write this equation. You say that x squared minus alpha plus beta, that is sum, and then plus alpha times beta, that is product. That becomes the equation. So if I pick this now, I'm going to find half of this and then equate it to the product just like this. So half of 3 over 2 is 3 over 2 times 1 over 2, which is 3 over 4, right? So let me use that here. Now 3 over 4 minus u into 3 over 4 plus u will give us the product, which is equal to negative 5 over 2. Now, I pause this at this point in order to solve that quadratic equation. I'll now bring it back and continue the solution when I'm done with this. Okay, so let's look at this. If we expand these brackets, 3 over 4 times 3 over 4 will give us 9 over 16 minus u squared is equal to minus 5 over 2. Now, if I want to make u squared the subject, I will need to use the additive inverse of u squared and that of negative 5 over 2. So I'm going to have 9 over 16 plus 5 over 2 is equal to u squared. Okay. Now at this point, you multiply to make this 2 to become 16 so that the addition will work well. Multiply up and down by 8. This will become 49. So that will be 9 plus 40 all over 16 is equal to u squared. That will be 49 over 16 is equal to u squared, which implies I take the square root of both sides. U is equal to plus minus 7 over 4. Now you put 7 over 4 here, we are going to have 3 minus 7 will give us negative 4. Negative 4 over 4 will give us negative 1. So we say that x is equal to negative 1. Or now if we put 7 over 4 here, we'll have 3 plus 7, that's 10 over 4. So that will give you 5 over 2. Because 10 over 4 is something as 5 over 2 or 2.5. So from what we have done so far, it is clear that, can I wipe this off? Please look at it so that I can wipe it off. Copy first. So let's continue with our solution. So we have here at this point that, sorry, I use x, but I'm supposed to use y. So that is not what I intend to do. It's x. It's y rather. So y is equals to negative 1 or 5 over 2. Okay. So at this point, let's go back to the intention of the question. We were told to find the values of x and y. Now, let's go back to equation 1. If y is equals to negative 1, right? That means y squared will be equal to negative 1 squared, which is equal to 1. And that simply means that x will be equal to 1 because x is equal to y squared. Look at it on equation 1. But if y squared is equals to 5 over 2, now it implies if y is equal to 5 over 2, it implies that y squared will be equal to 5 over 2 squared, and that will be equals to 25 over 4. So which means that, please, I can wipe this off. So which implies that our x is equals to 1 when y is equals to negative 1. And our x is equals to 25 over 4 when y is equal to 5 over 2. So we have a list of our solutions on the board. Even though the question looks so simple, but you can see that the solution to this problem needs us to use good wisdom in breaking it down. I want to appreciate you for watching our videos. Do not forget to subscribe and share to others. Thank you so much.